Thanks for listening to the Lake Doctor podcast. I'm Susie Light, and my co-host, Dr. Nate Bosch, is a professional lake nerd.
That's true, Susie. I received my doctorate from the University of Michigan in limnology, which is the study of freshwater lakes. In today's episode, we're excited to have Aaron Voirol. He's a hatchery biologist with the Department of Natural Resources as part of their fish stocking program throughout the state of Indiana.
We are so excited about today's episode. The doctor is in. So thanks for joining us today, Aaron. Aaron Voirol with the DNR, a fish hatchery biologist. Aaron, tell us a bit about yourself, your career journey, your relationship with the Lilly Center for Lakes and Streams.
Yeah, so I grew up in kind of the Warsaw area, Milford, Indiana. Went to Walleye High School. Graduated high school in 2015, and kind of was thinking about what my next career thing would be, and kind of wanted to play baseball somewhere. I love playing baseball at an early age, and played all the way through high school. I was a left-handed pitcher.
Southpaw.
Yeah.
Batted a little bit too. Played outfield, first base. I was left-handed, so I'd be able to play first base a little bit. But I kind of got interested in that, wanted to play at the next level, and the coach at Grace at the time, Bill Barr, came and watched one of my games, and got me down for a visit, and loved campus, loved his program and kind of his plan for the program, for the baseball program specifically, but I wanted my next career to be more involved with the environment and particularly the fish, and so I wasn't sure exactly what Grace offered at the time, but when I walked through the Science Center doors, I seen a fish tank going up the stairs, and I knew at that moment that this was the place for me. I hadn't met Nate before, but after meeting Nate, then that really sealed the deal. So yeah, Nate, I worked for Nate for 4 years at the Lilly Center. I majored in environmental science. Did a lot of the stream sampling that he offers and the lake sampling in the summer. I worked 4 summers here. Got to meet all the boat captains that are now more famous than probably when I was there. But they definitely helped out a lot with going around to different lakes. And I knew a lot of the lakes from growing up in this area, but there were several of them that I didn't know, and learning more about the water quality of those lakes and kind of how fish kind of work in that environment and kind of that relationship with water quality and how fish kind of react to that. So I did that for 4 years and learned a lot under Nate. I didn't really learn a lot about fish culture and different things like that in college, but working under 2 guys that have 80 years experience has been a blessing of mine. Be able to learn under them. So I'm definitely taking that opportunity and making the most of it. But
So Nate, the secret to success, getting kids in to see the fish, huh?
Yeah. Well, it was so much fun having Aaron as a student at Grace College in our environmental science program. I can remember some of that interest and some of those skills he brought in with him. I don't think this is a real thing, but I'm going to make it up. He had a fish IQ as well as a boating IQ that I didn't have. I know a lot about lakes as a researcher and did fishing and boating growing up, but not near as much as Aaron did. And so I can remember him coming in and we needed local native fish for some of our aquariums, for our aquarium program, and Aaron knew all the the hot spots of where to get those fish, and certain creeks or streams and certain types of traps. We have a special purposes license with the DNR to be able to pull native fish from different environments around northern Indiana, and Aaron knew just the right places and techniques to be able to pull those fish in. And then boating IQ, as I mentioned as well. We did a research study one time looking at boating impacts, and he just knew how to move boats in different places, and he had these little buoy things that I was just the little buoy markers that I was it's almost like a dumbbell sort of with the sides, and then it had a string in the middle with a lead weight on the bottom, and you would just throw it in the water. The lead weight would move down the water column, and so the sides would turn until that weight hit the bottom, and it would stop turning, and it would let out just the right amount of line then for that depth of water, and those would stay there. You could have waves and wind and everything, and they would stay there. And so as we were doing sampling and stuff, they would mark our different locations. And I remember just being so impressed at this young man and all of these extra tricks that he had. But then he brought in great enthusiasm into doing research, and some stream research, some lake sampling that you did as well. And now it's fun working with him as a professional, talking about fish, and even he does some fishing guide work on the side. And so I've got to hire him to take out some of our supporters going fishing on local lakes. You know, some people use golf as a way to connect to people and network out on the golf course. That's not so much my thing, but fishing is the thing that we'll do at the Lilly Center with some folks. And so it's just a lot of fun. Then those supporters get to see one of our students who's graduated and is doing a really good job in his career. And so that's been fun.
So tell us about your journey, like after graduation. Did you just apply to the DNR and they said, yeah, come on board? What was the deal?
Well, I mentioned to Nate, later on, right before I graduated, what's the next thing that I need to do? And he got me in touch with Matthew Lynn, who's a fisheries biologist at the Columbia City office, DNR office, and kind of got my foot in the door. And I was working under a fisheries biologist, doing surveys, doing water quality, kind of brings in like the Cisco, Cisco conservation that we did.
Okay, now wait, Cisco. What's Cisco?
Cisco is a salmonid species of fish.
Which means it's like in the trout family.
Okay.
Yep. There's several lakes that used to have a bunch of them in northern Indiana. They require really cool water at a very high oxygen. So in the summertime is when it's the lowest oxygen because it's the warmest temperature. The very low part of the lake, the very deepest part of the lake, the oxygen will, and Nate can talk about this, it's one of the things I learned at Grace College, but the very bottom of the lake, there's no oxygen, and then there's a certain point where that oxygen creeps up a little bit enough to support fish life. And usually so it's so deep, it's a lot cooler water. So Cisco needs enough cooler water, plus it needs that oxygen at the right amount too.
Yeah, so let's dig into why that's the case. So in our lakes, typically we have a stratified water body, which means a warm water layer at the top and then a cold water layer at the bottom. The cold water is denser than the warm water. The warm water warms up because it's warm air in the summer. Sunlight warms up the surface water, and so those two don't mix. So as you go through the summer months, that bottom water layer is isolated. There's no plant activity down there producing oxygen through photosynthesis. There's no ability of waves and air to diffuse oxygen into that lower. And so instead, the only thing that's acting on that lower water layer is bacteria. Cisco that wants that cold water habitat. And that's actually been a change that we've seen in some of our lakes going back to, I believe it was 1920. that are growing in our lakes because of more nutrients feeding those weeds and algae. And then when those weeds and algae sink to the bottom and decompose, they use up the oxygen. Oxygen layer is growing, and the has oxygen layer is shrinking. And so that layer where the fish can survive shrinks. And so some fish like bluegill or largemouth bass, they're fine, right? They can deal with warm water, plenty of oxygen, whereas a cold water species like the Cisco, they need the cold water at the bottom, but there's no oxygen. And so a lot of our lakes have squeezed Cisco out of where they once would have been able to survive. And so I think there's only now a few lakes in Indiana that can support them.
From what I understand, there's only about 6 or 7 lakes that have a good, solid, they're reproducing population.
So at the hatchery, do you grow Cisco?
No.
Okay.
Nope. There's not enough lakes that even if we would stock them in, they wouldn't survive.
I see.
The lake itself just can't allow them to survive.
So tell us what you do with a hatchery.
So I am the hatchery biologist at Fawn River State Fish Hatchery. I've been there since 2021, June of 2021. My main work is fish culture, feeding programs, allowing fish to basically just find the best possible route for fish to grow the best that they possibly can.
So I imagine the work that you did when you were at Grace College, the Lilly Center, do a lot of data collection. And how did that help you with what you're doing now?
With our programs and stuff, we get one chance a year to raise fish. You start in the spring, you grow the fish, then you stock them out in the fall, or you start them in the fall and you stock them out in the spring. So you get one chance a year to grow your fish and then stock them out. So there needs to be a lot of data collection during that time so you can learn as much as you possibly can so that the next year you can improve your production. That's one of the biggest takeaways I've taken away from working at a hatchery, and it's gathering data and writing things down when certain things happen, when the fish aren't growing real well. This year, what makes some changes for next year, and these are the changes we're going to make.
So you're saying some of those reports I made you write as a student and those spreadsheets that you had to keep track of and all that data is actually helpful now in real life?
Absolutely.
Oh, that's good.
I may not have liked them at the point of time, but very beneficial.
I wanted to ask about, you mentioned hatchery and you have fish when they're smaller and then you give them to a different hatchery. How many different hatcheries are there around Indiana? And it's really cool that you guys all coordinate with different expertise with certain fish or different facilities for bigger or littler fish. Give us a sense of kind of the big picture of Indiana and how hatcheries around the state work together.
So we've got 7 hatcheries in our state. We have 2 that are cool water, which are more trout, salmon. They're kind of more based out of Lake Michigan. They support Lake Michigan, that little sliver.
So I'm going to guess in the northern part of Indiana?
Yes.
Okay.
Well, that's like that little sliver of Lake Michigan that we have in Indiana. That's what they're stocking into. But the other hatcheries are more the cool water, where we raise walleye, where we raise muskie, bluegill, largemouth bass, different fish like that. Then we have three hatcheries in the south and 4 in the north. And we work together with the south ones throughout the year with moving fish to one hatchery, then bringing us some fish. It all kind of intertwines. We all help out and work together.
So in Kosciuszko County, there are a couple of lakes that get stocked with fish. We know that Winona Lake gets some. What other lakes and how do you determine which lakes get what?
Yeah, so that isn't really my decision to make. The fisheries biologist, I'll determine where these fish go. My job is just to raise them, get them as big as we possibly can.
And that would be like Tyler DeLauder, who we've talked to on this podcast as well.
Yep, Tyler would be this district. And we have Matt Horsley, who's District 2. And then Courtney Weldon is District 1.
So we learned that lakes in our community all have different temperatures and different kinds of environmental environs. Is that the right word? They have different environs?
No, like different habitat types.
There we
Is
go.
that
Different
what you're
habitat
looking
types.
at? Yeah.
So some fish do well in some lakes in our county and other fish don't because of the oxygen levels and because of the temperatures.
Yeah.
So muskie, do you stock muskie in our county?
We do. We don't stock too many. We will sometimes overwinter a few thousand muskie and just kind of help supplement some lakes that haven't gotten them in the past few years, just to kind of help boost that population. We do.
You're speaking of your hatchery in particular.
Yes.
There's another
yes.
hatchery that
Yeah.
does more of the muskie.
Correct.
Right?
Correct. Yeah. There's a hatchery, East Fork State Fish. Throughout the summer, kind of like what we're doing with our walleye, they're doing the muskie, and then they bring them. They're the ones that stock them out in the fall.
So if
Yeah.
I have, I wish I had, if I had a lot of acreage and I had a pond or a lake on my own property, could I like call you up and say, hey, Aaron, I need some fish?
Not exactly. We only stock public bodies of water, so any lake with a public access, since those are where any angler can fish that lake, and they're paying for their license, and that money's coming back to us. So we have to follow through with stocking lakes only with public bodies, public accesses, or anything like that, and then all throughout
That
the
makes
state.
sense.
There are
Yeah.
commercial hatcheries as well. And so you as a private pond owner potentially could go to a commercial hatchery and purchase fish to be stocked in your pond. But yeah, you wouldn't be able to use the DNR public hatcheries for that.
So tell us about Cisco and your work with Cisco.
So when I was in the Columbia City office, I worked under fisheries biologist Matthew Lynn, and our main goal was to kind of monitor the water quality in some of the lakes that did have the Cisco, and try to protect by monitoring and making sure that the oxygen was suitable for them. Later in the fall, August, September, when the oxygen is the lowest, is usually when you'd have some fish kills. Just some of those ones that got real stressed out, they just didn't make it. So we'd go out and collect a lot of those fish that did perish. But our main goal was to kind of just make sure that the fish were still in there, and because they were able to be caught. The people could go out and actually catch them and take them home. So we were monitoring, making sure that populations were still good. And if the population would ever get down to a certain point, we'd have to shut fishing off and protect that resource from, for the future. And I was a part of a krill survey. Matthew Lynn let me
Explain
do a krill survey.
Explain krill.
Krill survey is basically a interview where I go out and I interview fishermen and see what they're catching, how many fish they're keeping, taking home. And this one was specifically for Cisco on a lake in Noble, Whitley County, a Crooked Lake, which probably has the best population of Cisco in the state at this point. And so my job was to go out, see what people were catching, how many they were taking home, and kind of help get a basis of how the population's doing and how many actually people are fishing for them. And that
Okay,
was kind
Aaron.
of the last thing.
It's usually a joke that fishermen tell tall tales.
Yeah.
So if you're doing a survey of fishermen and you say, like, how many Cisco did you really catch?
Right.
Like, they honest with you?
Yeah, I mean, I would ask them to kind of see your fish, get some measurements on them.
So there's some accountability there.
Right, and they can decline. Like I'm not a conservation officer. I'm not an officer. I can't, So it was mainly if the fisherman was willing to give me that information, I would take it and get all that data.
In the name of science.
Yep.
Right?
Exactly.
It's good.
Exactly. Which we had, obviously now the Cisco, where we cannot catch them and keep them anymore. They're considered now endangered. So that was after that krill. That next year you couldn't catch them. So maybe the data hurt them. I don't know.
Well,
They
give
can't
the
take
krill a
home, so-
chance to come back, right?
Right. Hopefully, but it doesn't look that way for the future, but you never know.
I think it might be good to take a step back here at this point and talk about why is it even important to stock these fish in our local lakes. And this reminds us of some of our conversations on this podcast talking about food chains in lakes, right? And so the fish that you're stocking are typically the top predator fish, right? Top of the food chain.
Typically, yeah.
Yeah, so they would be piscivores, meaning they're eating other fish. So our walleye, our muskie, our Cisco, the trouts, so they're the big fish, and they're eating the smaller fish. We call planktivores, and they're called planktivores because they eat zooplankton. And so zooplankton then is our middle layer, and then those zooplankton are eating our phytoplankton, also known as our algae. And the algae is what often gives our lakes more of a cloudy appearance to them,
Right.
more of a green-brown sort of color. And so when we look at our lakes and we see they're kind of a greenish color and they're being overproductive and they're causing low oxygen levels, then the management question is, okay, well, what do we do about that? And you can have what's called bottom-up control, where you limit the nutrients that are feeding the algae, or you can do top-down control, which is what DNR is helping to do through their stocking program. Top-down control is where you add more top predator. That means that next layer down will have less, because with more predators, they're going to be eating more of those smaller fish, the planktivorous fish, which means you'll have more of the zooplankton, that middle layer, which means you'll have less of the algae, and the lakes will be clearer and they'll be less productive. So you can actually make a lake healthier by having more top predators because of that sort of trickle-down effect. We call that a trophic cascade, where it moves down through the different food chain links.
So let me take that a step further in that we knew that the Cisco were a large predator, but people were either overfishing or the Cisco weren't healthy for some reason, and that's why we had to stop allowing fishing for Cisco.
Part of it, but a Cisco is they eat plankton. They eat really small.
So Cisco's probably
foods.
not a good example
Okay.
of the trophic cascade,
Right.
but a muskie, which are also
Right.
stocked, or a walleye, those would be better examples.
Right.
And you're right, Susie, if we insert ourselves as the new top predator, and so we're eating, so Aaron said he loves on the lake, and he's eating all these walleye, and so the walleye population's going down. That means that planktivorous fish, the small fish, the perch, the bluegill, that population's going to go up, which means the zooplankton population's going to go down, which means the algae population's going to go up, right? So we want to control how much harvesting we're doing of those top-level predators so as not to have the opposite top-down control that could be negative, and instead keep those predator fish in good high populations that are healthy, and then that keeps everything else ordered down below. It's important work that you do.
Yeah, the main reason we do a lot of these stockings with these higher top predators is, one, help improve the angler catching them and going to Webster Lake catching a muskie, or going to Winter Lake catching a nice walleye. We want to keep increasing those numbers of fish, but yet we don't want to stock too many of them. We want to be able to grow and get to legal size where people can catch them. So we do have certain guidelines that kind of help with how many do we actually stock. And it's based on acreage, so that we get an even number across different lakes that are smaller, larger. Fisheries biologists, they require that 10 per acre with these advanced walleye fingerlings that we do. So, lake like Winona Lake, 5,600 or 560 acres, we stock 5,600 walleye. So a lake like Lake Wabasee, 3,000 acres, we'd have to stock 30,000 fish, which we just don't have the capacity to do that. But if we did, maybe we would. I don't know.
So Nate, you mentioned that people can be the top predator, and in their fishing activity, do people need to be careful about how much fish they consume? Like you just said, Aaron's going to eat all those walleye in Winona Lake. Like, do we need to be careful about that?
Yeah. So some contaminants in our environment, these water ecosystems, can move through the food chain. And we have what's called biomagnification, where you can magnify the level of toxin each level of the food chain that you go up. We also have bioaccumulation, which means as a certain individual fish lives its life, it accumulates more and more of that toxin in its tissue. And so we've been talking about Winona Lake for some of these examples. In the case of Winona Lake, for example, 10 years ago, we would have had a consumption advisory for Winona Lake that would say, in general, people should not eat more than one meal of fish per week in order to still stay healthy as a person. And then pregnant or nursing women were not supposed to eat any meals of fish from Winona Lake. Now, that has been adjusted here more recently such that there's now no limit. There's no consumption advisory for Winona Lake for the general public. There's still a little bit of a limitation for pregnant and nursing mothers. And so that has to do, I think in the case of Winona Lake, it's mercury. And so there's some of these toxins that are in the sediment, often from different industrial processes long ago that accumulated in the sediment. There's small invertebrates in the sediment that get eaten by little fish, that get eaten by big fish. And then when people eat those big fish, then all of that toxin that's accumulated in all those individuals then gets in our own tissue as we're eating those large fish. And mercury is toxic to us. Our body doesn't have a way to metabolize it and get rid of it. And so it accumulates until it could start causing health impacts. And so the DNR has these consumption advisories, and you can go to the DNR's website and see those. We have, for our lakes in Kosciuszko County, we have all that data on our Lilly Center website as well. And so you can go right to your consumption advisory. You know exactly how, sometimes it's for certain fish, like carp often have higher consumption advisories because carp are often eating down near the bottom where a lot of these toxins are accumulated. And people then can know and with confidence, hey, I can catch and eat fish from this lake and not worry about any adverse health effects, or maybe other lakes have a consumption advisory, and so people can be informed then to know what they can do.
One of the things that we talked about, muskie, but in the information we have, tell me, what is a muskie spawn? Dave
and Tom, the property manager, assistant property manager, this was their program that they started back I don't even know how many years ago. Many years ago. I want to say back in 80s or 90s. And this is done at Webster Lake. So our Webster Lake is called, we call that the brood lake for our muskie program. So a brood is a fish that we will spawn, take the eggs from, and to make more muskies. That's like basically the parent of the program. So we go over to Webster Lake in the spring before the walleye or before the muskie are spawning, and we will take roughly between 15 and 20 females, and we'll spawn them, and then we'll get males, get the melt, and fertilize the eggs, and then we raise those eggs into our hatcheries, and then kind of start the harvest kind of growing season at our different hatcheries in the state.
Okay, so you harvest females before they lay eggs. From North Webster Lake. And then you harvest the males, and
we're doing that simultaneously.
Okay.
At the exact same time. We have a place over there that one of the he's actually a fishing guide for muskie, so it kind of works pretty well. But he lets us go over there, and we work right in the channel where he lives, and it allows us to work right on the water and bring those fish in, spawn them, get the eggs, take them back to our hatchery, and then we can kind of start the process of growing them out.
So spawning would be the natural reproductive process that fish would have in certain water temperature conditions at certain times of the year. They often are picky about certain bottom substrates and in certain streams around. And so what they're doing is they're sort of artificially bringing them to do the spawning in more controlled conditions to have a higher survival and a higher hatch percentage, so that then there's more fish to go and stock later. So they're taking a natural process, doing it somewhat artificially in kind of a controlled environment to have bigger success then.
So one female muskie has about how many eggs?
So it ranges a little bit depending on the size, but 1 quart of eggs is roughly about 40,000 eggs. And we'll have about 15 or 20. So kind of do the math. We'll have
15 to 20 females will produce all 500,000 to 600,000 eggs.
Yep. We've gotten upwards of almost 1 million eggs. We just certain days are a lot better than others. Like we'll go over and we'll spawn, 1 fish one day, and then the next day we'll go and we'll spawn 9 or 10 fish. And we want to make sure we have enough, because you don't want to get in a bind where, a lot of the eggs didn't fertilize properly, or a lot of them died, and then now you're kind of short. So you always want to get more than what you actually need. But we haven't had any issues since I've been around. I don't know. It's been going on for many, many years. We've had the one day. So you do have days like that too.
That's a fishing term, getting skunked.
Mm-hmm.
Yeah.
Mm-hmm.
Not a fish.
Not a fish.
Not a
successful.
fish.
Yep.
How, if you have the 500,000 to 600,000 eggs, how many stockable muskie does that translate to after that growing season that you have there in the hatchery?
Yeah, so it's not very high. If we can get 15,000 or so, I think that would be pretty good.
But in the natural environment, it would be way lower than that, the survival
well,
rate.
And muskie can't properly spawn in some of our lakes because the substrate is just not good enough. Like you were saying, there's a lot of sediment going around, and it when the eggs get released from the fish, it just covers up the eggs and suffocates them. So there probably is some natural reproduction of muskie, but it wouldn't be enough to sustain it, and it's the same for the walleye too.
And speaking of walleye, you're involved with American Fisheries Society, and I remember you telling me this past fall that you got elected into a new position there with the society related to walleye. Tell us a little bit about that.
So this is a walleye technical committee. It's in the North Central District, so it's Minnesota, South Dakota, North Dakota, Missouri, basically all the Midwestern states. And it's a chapter where we get together during certain meetings, like the summer meeting and the winter meeting are the main two. From one another on how to better our walleye populations in our lakes in our own states.
Give us an example of a walleye project that might be happening.
This is just probably one that's typically done, is looking at a specific lake and understanding how the fish are surviving, looking at different strains of different walleye that are stocked. Some of them are from private hatcheries, some are from state hatchery. That's kind of one of the things that we're doing. Some of them are even looking at habitat for spawning. Where they're spawning and why they're doing it there. A lot of it can be looking at hydroacoustic tagging, being able to they tag walleye and they kind of see how they're moving throughout different water systems, behavior, different things like that. Because a lot of the lakes in these other states are, they're huge. They're mammoth in size, or 20 miles by 10 miles wide. They're just huge lakes where they want to understand where these walleye are going. Because they are naturally reproducing in a lot of these lakes too. So they want to understand more about it. So that if they do see trends in the downward they can kind of make some assumptions, or I guess they don't want to make an assumption. They want to dial it right in to figure out what's going on. But it's a lot of data collecting and presenting why these fish are behaving the way they are and stuff. It's mainly just a place where all these professionals get together and we present our information and kind of more understand what walleye are doing in a lot of our northern Midwest lakes.
Pretty impressive. You, young in your career, already going to be chair of that particular group within American Fisheries Society.
Yep.
Congratulations.
Yeah.
That's pretty cool to be known to be a nationally recognized walleye expert.
Right. And next summer, we're planning on going to Beaver Island on Lake Michigan and having our meeting out there. So.
Oh, man. So you guys get to go to cool places for your meetings, too.
Yep.
Huh?
Yep.
I think Aaron's time at the Lilly Center has been a positive impact on his career.
Sounds that way. Yes. So
absolutely.
I love hearing not only we've talked about his passion that he brought into the Lilly Center and how it benefited the Lilly Center and our research and some of the projects we were doing with aquariums, going out into classrooms and things like that. But then that interest and passion he brought in then has also allowed him to grow in certain areas like data collection and research, which is now impacting him in his career. And he's now having this multiplying impact around the state of Indiana and throughout the whole country with this role that he has. And
impacting the environment and the citizens of our state. Exciting stuff.
I got to give a lot of credit to Nate and being able to take a chance on me at the Lilly Center and be able to work and, get to know people in the community. And, I think that's what it's all about is our citizens of Indiana, the people that love to fish, love to use our lakes as either recreation or for fishing or whatever they're using it for. We're stocking these fish for them. We're working for the citizens of Indiana to better the lakes and the rivers that we offer for good fishing and recreation. So
we're going to give a tip of the hat to your mom and dad too for raising
absolutely
a family of fisher people.
Absolutely. Yep.
Yeah, that's for sure.
Well, Aaron, thank you so very much for joining us today and sharing your information about fishery biology at the Department of Natural Resources, DNR. And thanks, too, for sharing your journey from Wawasee High School to Grace College through the Lilly Center. It's exciting. As a grandparent, it's exciting for me to hear the opportunities that are available to kids in our community to really make a difference in the world. And we appreciate that you're doing that. Thank you.
I can't stress this enough that Grace gave me the opportunity. I don't know if I would be in this seat right now if it wasn't for Grace. So it's a great feeling to be able to go through the Lilly Center and be able to work under Nate and all the expertise he offers. So
thank you.
Thank you.
Yeah, thanks. We're proud of you. Hey, I'm Dr. Nate Bosch, the director of the Lilly Center for Lakes and Streams. We're on the Lake Doctor podcast here, and with me, Matt Burlingame. Matt, what do you do at the Lilly Center?
Hey, Nate. I'm the assistant director of research, so I'm in charge of our research projects that we do at the Lilly Center.
All right, and your expertise is fisheries biologist, right?
Correct. I have my bachelor's degree in fisheries and master's in biology with a concentration in fisheries. I worked as a research biologist with the DNR for about 5 years, and also did some data analysis with them through fisheries research as well.
Cool. All right, so today we're talking about fish, and we've got an aquarium here in front of me. Those of you who are listening on the podcast, this might be an opportunity for you to switch over and actually watch this segment on YouTube. We've got an aquarium that normally is in the back of our set here on the Lake Doctor podcast. We've moved it right up front and center onto the table in front of us. And so we're going to go through some of these fish, talk about different characteristics here today. So Matt, why don't you take us through the fish that we have in this aquarium, what type they are, and how you know that they're those type.
Okay, well, we have 3 different species in here and also 3 different families of fish represented. The black one here at the top, kind of football shaped, that's a black crappie. And the little one, as well as a black crappie, is kind of faded out. They were saying that the channel catfish was nipping at him a little bit. Maybe he's a little bit stressed. Black crappie and white crappie are in the sunfish family, Centrarchidae, along with bluegill and long ear and red ear and pumpkin seed, and also largemouth bass and smallmouth bass. Okay. And then the other species here, with the yellow orange fins and the dark bars on the side, that's a yellow perch, part of the perch family, related to walleye. And then the last one down here is a channel catfish. You can tell it's a young of the year by its spots. But they're in, obviously, the catfish icthylurid family.
We have different body shapes here, so maybe tell us a little bit about the anatomy of these fish as far as what the different parts of the fish are called, maybe the different fins, because obviously we have some different shapes and different fins represented here.
So I think this perch is kind of up in the front. So the fin on the top on their back is called a dorsal fin, and a lot of fish have, we call a spiny dorsal fin and a soft dorsal fin. So the spiny dorsal fin is the one at the front. A lot of times they'll have spines. So the black crappie and the perch, those first couple fin rays are actually spines, and they can poke you and they hurt. And then obviously their tail fin is called a caudal fin, and then the fins coming out by their gills on the side, so they'd be like our arms, are pectoral fins. Okay. And then the pair of fins underneath are pelvic fins. I guess with the channel catfish, he's got this little. And catfish also have spines in their fins. They have spines on their dorsal fin, one spine, that first ray, and then the first ray of their pectoral fins on the side have a spine also. And a lot of people think that channel catfish, their barbels, their little whiskers, or their spines will sting you. They're poisonous. That's not true. Okay. But if you get stuck with a spine, it does hurt very bad. And, and those spines are also serrated, so if you get them deep in, they're hard to come out. So it's almost like having fishing hook barbs along the back of it. So.
Okay. What about any other interesting characteristics about either the perch or the crappie that you can tell us about?
Well, the crappie, you can tell its body shape is kind of compressed. We call it laterally compressed. And black crappie, like a lot of sunfish, like bluegill, like to hang out in the aquatic vegetation where they can pick maybe aquatic insects off the vegetation, or crappie a lot of times will eat minnows, eat small fish, so will ambush out and can attack. Perch a lot of times will be in the vegetation as well, but a lot of times they'll move out into deeper water in the summer when the water warms up, and it will kind of school out there. They're piscivores, so they'll eat minnows, smaller fish primarily, but zooplankton and other things. Channel catfish, most people think they're bottom-dwelling trash fish. They will eat just about anything, but they're essentially predators as well.
So Matt, you mentioned about the catfish here that it was young of the year, and you could tell that by its spots. So tell us a little bit about how do you age fish, the fish that are in this aquarium right here, how old do you think they are?
Okay. So most of these, based on size, are probably what we call young of the year, although these this bigger black crappie we got last year, so he's probably going to be a 1-year-old fish, and probably the same with the perch. Again, the channel catfish, when they're juvenile, so younger, that can be 0, 1, 2, 3 years probably, they'll have black spots on them. And actually their scientific name is Ictylurus punctatus, and punctatus means spotted.
Oh, interesting.
So channel catfish, we can age them and the other fish as well, but 2 different methods. So for most fish that have scales, when we capture them in a survey, we'll scrape a scale off them, and we'll take that scale back to the lab and press it into a plastic microscope slide, and it makes an impression. And fish scales, just like, well, how do you age a tree?
Yeah, with the tree rings,
Tree
right?
rings. So fish scales do the same thing. So there's rings on a scale that we call annuli. And in the summer when they're growing, those rings are spaced further apart. And then in the winter, when water temperatures get cold, the fish growth slows down, so those rings stack up, so it makes like a darker ring. So we take those scales, press them on a slide, look at them under those microfish readers, and we can count how old the fish is. Okay,
just by a scale.
Just
and
by a
so
scale.
you're not killing the fish to be able to measure that.
Catfish don't have scales. So what you can do with a channel catfish fish, and then they use a jeweler's saw and cut really thin sections. And the spine, just like the scales, also put down rings. So it's almost the same process. Both of those are relatively accurate, but have issues with each process. And probably the best way to age a fish is they have ear bones like we do. So you cut the fish open, take out their ear bone, and you can cut them with a jeweler's saw. Sometimes you can just put a little drop of oil on them and read them whole. Obviously, we've got to kill the fish for that to happen, but that's probably the most accurate way.
Because those ear bones are internal.
Right.
Correct. Is that called otoliths?
Otoliths,
I think I remember hearing
Yep.
about that before. All right. So tell us how the life cycle of these fish goes. So you talked about most of these fish are pretty young here. How did they start their life, and maybe how big? We talked about how big the catfish can get, but maybe some of the others, how big can they get?
So we'll start with the crappie. So a sunfish, they'll build a nest like you've seen in their sand around the lake, those little moonscape that creates the males dig a nest. They convince a female to come, and they lay the eggs and fertilize them, and then the male guards the nest, and eventually those eggs hatch, and they stick around the nest for a while, and then they disperse and go on their own. Channel catfish, similar. The male will find a nest. They like to breed in cavities. So a similar thing, they'll find a cavity, and if they can't find a cavity, they'll also try to dig some kind of depression to lay their eggs in, convince the female to come, and they'll lay the eggs, fertilize them, protect the young of the year, the fry for a while, and then they go off on their own. Yellow perch are interesting because they'll, when they spawn, they don't build a nest. It's more of a broadcast
Method
spawning. And perch eggs, if you go out in the lake early spring, kind of after ice out, sometimes in the shallow, you'll find long ribbons of white, like gelatinous ribbon. Sometimes kind of almost like in a double helix, like a DNA molecule almost. But it's perch eggs. And so when the perch female lays her eggs, they'll swim in a circle and drop the eggs, and those eggs will attach to vegetation or woody debris, branches or something in the water, or even just lay on the bottom. But I was telling you before, when I worked with the DNR and we do broodstock muskie collection at Webster Lake, a lot of times there'd be perch eggs stuck on the leads of the nets and stuff. So
that is really cool. And so those perch eggs will connect onto each other.
It's just like one big ribbon.
And then you said fry, so that would be the fish when so you've got larval fish.
Larval fish will still have part of the yolk sac on them, and then once that yolk sac is gone, then they're fry. And then they become, as they get, finger size, they call them a fingerling.
Well, another thing we wanted to talk about with these fish in this aquarium here is to tell you about the Lilly Center for Lakes and Streams aquarium program that we have. We have both the classroom lake experience. We also have the lake in the library. And these are programs where we bring aquariums similar to this, only this is a 10-gallon aquarium. We bring 40-gallon aquariums into local classrooms, into local libraries, into local community centers. And they have fish just like this, local native fish from our lakes here in northern Indiana. We've actually also been starting to experiment with live plants. So the aquarium in front of us here has artificial plants, but we have live plants. We're using a lot of eelgrass in those live planted aquariums to try to get both native plants as well as native fish both in the aquarium to be able to really highlight our lake ecosystems and how they operate so that students from their desk or patrons to the library or community center can start to learn more about these really cool creatures. We usually will have a library of books that go along with them, some curriculum that will go when it's in classrooms, and we'll have one of our educators come out and talk about those fish, and it's really a great program. So, all right, well, thank you, Matt, for being here and teaching us a little bit about these fish.
I'll talk about fish anytime.
Okay, sounds good.
Thanks for listening to this episode of the Lake Doctor Podcast. Please like, subscribe, and share, and make sure to join us next time. It's bound to be fun.
Listening to this podcast is just the first step to making your lake cleaner and healthier. Visit lakes.grace.edu for more information about our applied research and discover some tangible ways that you can make a difference on your lake.
If you have a comment or a question that we can discuss in future episodes, leave a comment or send an email to lakes@grace.edu. We'll see you next time. The doctor is in.